New Year's Asteroid Strike, presented by Science at NASA. In 2014, the new year began with a bang on the order of about 500 tons of TNT. That's how much energy asteroid 2014 AA is estimated to have delivered to Earth's atmosphere when it exploded over the Atlantic Ocean on January 1st at approximately 11:10 p.m. Eastern Standard Time. 2014 AA was the first asteroid discovered in 2014. Astronomers of the Catalina Sky Survey found it during the early hours of January 1st using one of their telescopes near Tucson, Arizona. Our encounter with this space rock the size of a small compact car didn't last long, however. It was only 21 hours before it crashed into Earth's atmosphere. No damage was done, says Don Yeomans of the Near-Earth Object Program at NASA's Jet Propulsion Laboratory. It disintegrated harmlessly high above Earth's surface. Asteroids the size of 2014 AA hit Earth several times a year, so there's nothing remarkable about such an impact. What's interesting is that it was seen before the impact. This is only the second time that astronomers have detected an Earth-impacting asteroid before it hit. The first time was back in October 2008, when another small asteroid, 2008 TC3, hit Earth's atmosphere and broke up over northern Sudan. As many as 600 small meteorites were recovered from the Nubian desert after that crash. Fresh meteorites, especially those that are associated with a known fall, are scientifically precious. The treasure was made even more valuable because Richard Kowalski at the Catalina Sky Survey had discovered the asteroid about 19 hours before impact. Astronomers then had time to observe the object while still in space, so that researchers could compare what telescopes observed with the material that was later recovered on the ground. At first, 2014 AA seemed to be a case of deja vu, a 2 to 3 meter asteroid discovered by Catalina almost a full day before impact. But in this case, the asteroid would impact over open ocean where no meteorites could be recovered. The impact location was later pinpointed using data from a network of infrasound sensors operated by the Comprehensive Nuclear Test Ban Treaty Organization. While this global network of detectors was originally intended to monitor for nuclear explosions that may violate the treaty, it can also be utilized to pinpoint airbursts from entering meteors. Infrasound is a type of very low-frequency sound wave that only elephants and a few other animals can hear. Meteors penetrating through Earth's atmosphere cause ripples of infrasound to spread through the air of our planet. By analyzing infrasound records, it is possible to approximate where a meteor exploded and how much energy it unleashed. Weak infrasound signals showed 2014 AA probably disintegrated over the Atlantic Ocean east of Venezuela, in good agreement with a ground track calculated by Steve Chesley of JPL using the observations taken when it was discovered. I estimate that some 10% of the asteroid's mass could have reached Earth's surface in the form of ponderable-sized meteorites, says University of Western Ontario physics professor Peter Brown, who analyzed the infrasound. There is a good chance of a meteorite-strewn field, albeit in the middle of the ocean. Detecting asteroids before they strike is rare. However, Yeomans thinks it will become more commonplace in the future. There are more than 1 billion near-Earth objects in the few meter size range, he says. As discovery surveys continue to improve, we will detect more of them before they hit Earth. Early detection is, of course, the objective of NASA's Near-Earth Object Program's search for hazardous asteroids. 2014 AA is an example of what can be done with sufficient vigilance. For more on the detection of near-Earth objects, visit science.nasa.gov.